Hello, everyone. It is now 11 minutes after, and we plan at this point to have a panel discussion with the maintainers of the Einstein Toolkit workshop. This is going to be a somewhat free-form discussion. It can consist of questions from you all, or if you don't have an immediate question in your mind, we have a couple of them prepared. So just for the record, our maintainers are Roland Haas, Eric Schneider, Zach Etienne, Bruno Giacomazzo, sorry if I mispronounced your name, Peter Diener, and Ian Hinder, and myself. So, oh, and Helvi, I'm sorry, Helvi. I was reading off the email list from your mail, and your name was at the top instead of it being in the list.
It's okay.
Okay. So anyway, I'm glad to have all of you here. To start off with, is there anybody who has a question? I see no raised hands. So I guess the question I would put to the panel, and I would like us to consider is, what as maintainers, what are the things that you are looking forward to implementing, to adding to the toolkit in the near future? So you can raise your hands, I guess, and we'll just go in any order. Or I can pick people. Bruno.
Yes, so as I said, we're working on these new code spreads, and we would like to add this to the toolkit once it's let's say, ready for binary neutron star simulation. But something that is very important for us is a more accurate, let's say, evolution of neutrino emission, in particular using some, because at the moment we are using the Zelmani leakage scheme, which is open source, but it's only a very simple leakage scheme, while there are more advanced methods like moment schemes and so on. And I think there are many people that are interested in those. So I wonder if maybe we can try to work together on a sort of neutrino code for the Einstein toolkit that can be used by any other evolution code like Illinois or Spritz or Gerhydro or whatever. I don't know what other people think about that.
Do you have a particular scheme or algorithm in mind? Better than leakage? A particular moment scheme, a paper or something?
So I was thinking, so I'm not an expert on this, but from what I read from the paper by Francois Foucault, it seems like the M1 scheme is probably one of the best at the moment, used in binary neutron star simulations. And for sure, there could be something better than that. So.
Okay. And do you think you know when your code might be included in the Einstein toolkit? Do you have like a planned date or year?
For Spritz, don't know, because as I said, we are finishing testing the neutrino, and once the paper is published, we will update the version of Zenodo. And then after that, we will start working on binary neutron star. And if everything works as planned, then I think at that point, we will work on the inclusion of the Einstein toolkit. Because I think that in order to include that in the Einstein toolkit, for sure, we will have some work to do. I think a documentation or maybe some, I don't know, how the schedule or other things are written. I don't remember what are the requirements actually for the inclusion of a code in the Einstein toolkit. But I'm pretty sure there will be some work needed. And so I want to be sure that the rest of the code is essentially fine. And so we just have to do some minor modification, maybe for inclusion in the Einstein toolkit, and that's it. So I hope next year, but I don't know.
Okay, that's all I was looking for as a guesstimate. Who would like to go next? Helvi.
Yeah, so I can also add a few things. So as some of you may know, I've been working on a library for gravity beyond general relativity and using GR to test for light fields, for scalar fields, and for vector fields. That code is called Canuda and has been developed together with Miguel Ziliao and my PhD students, Matt Alley and Giuseppe Ficara. Part of that code is already in the toolkit. So if you see Procassorn or Lean, that's already there. But we also have additional arrangements for adding scalar fields, which is well tested and available publicly via our Git repository and on Zenodo. And we also have a arrangement for modified gravity, quadratic gravity. So if there's any interest to go beyond GR to do a strong field test of GR, these could be included. So the scalar field is Soren is very well tested, and we are updating the modified gravity part.
Okay. Who would like to go next? Roland, could I volunteer you?
Yeah, Zach had a hand up. Did he put it down?
I saw it just as I said your name. I saw it just as.
Okay, he's hiding now. So keep in, so I think there's two things to consider, right? So one of them is the point of view of being a maintainer of the toolkit, which at least when we initially came up with this really means you're looking at the toolkit as a whole and you're maintaining the toolkit. You're not, say, talking in, at least from, it's not the percentage who develops the new codes, in the sense that the toolkit would take codes that are already used by groups involved in doing research, and then either approach those groups for codes that seem useful or help groups make their existing codes available. So in that sense, now I'm talking as, say, a maintainer, and not so much as somebody who might be involved in research with various people here. So in that sense, for me, the interesting thing, of course, is going to be the Carpet X driver code that Eric in particular is developing. Yes, yes. And related to that, having a chance of finally getting some working and hopefully straightforward to use GPU support into the Einstein toolkit. The later one in particular is something where there is still, well, there's not much done yet. AMRX supports it, but there hasn't been anybody really who has made much progress adding it up. I know from some people that they're interested in doing so, but that's definitely something where we are not at the stage yet where we can say we have anything that's yet working where the toolkit as a toolkit could actually do something. And I think that would be of interest for lots of people to have GPU support in the toolkit. So that in some sense, I would like to get things into the toolkit that are of interest for people that want to do research, to make sure that it's available for them when they want to get started with things.
So Zach, do you wanna, since I missed your hand earlier.
It's all right. Yeah, so a couple of things. I've proposed inclusion of NeRPi-PN in the next version of the toolkit. So it's within NeRPi. Basically, it's exactly as it's described here, validated post-Newtonian expressions for input into other things if you want to use them. So for example, on the main page of NeRPi-PN, which is linked to from the main NeRPi, the main menu of NeRPi, this is something that's very useful, I think, for those of us who do binary black hole calculations. The big question is, what are the momentum parameters that you need for your initial data when you evolve a black hole binary, such that it minimizes the eccentricity. And what I've coded up in NeRPi-PN, the main reason I coded up NeRPi-PN in the first place was so that I can get these parameters out very quickly at the highest post-Newtonian order that's available. And this builds upon work done by a number of folks. And I cite all their papers here, and you can click on them and you'll see it's all nicely linked. But primarily Ramos Boades, Husa, Pratton, theirs I think is the state of the art. It goes up to 3.5 PN order. So you give it the binary parameters as input, and it will output for you using NeRPi-PN the quantities that you need to inject, right? So a black hole binary is not going to have zero radial momentum because it's radiating gravitational waves. So you have to include that physics in your initial data consideration. So that's one thing I proposed for inclusion, and that's going to be merged with a parallel effort in collaboration with Eli Huerta, Roland Haas, and Sarah Habib at Illinois, who are working on, so this is like a zeroth iteration for a eccentricity reduction code as described by Ramos Juarez et al. But this already gets you to pretty low eccentricities. So I think it may be good enough as a start if you want to do a black hole binary calculation with, and you're willing to accept 10 to the minus 3 eccentricities. The other thing, Illinois GMHD has recently been documented by Leo Vernick in pedagogical Jupyter notebooks alongside NERPy. Now, this is not a version that uses NERPy in particular, but it does use the NERPy style of splitting things up and providing links to all the various notebooks. So basically, if you go back to the main directory here, you'll see that every algorithm in Illinois GMHD is now documented properly. So I propose this for inclusion, but unfortunately this version of Illinois GMHD, which supports hybrid piecewise polytrope-based equations of state, is not fully backward compatible with the old version. And we've moved on now to adding tabulated equation of state support and neutrino leakage along the lines of Spritz. And Leo's in charge of that effort. And we hope to have that in the toolkit, you know, in the year time frame as opposed to the month time frame. So certainly not the next release, but stay tuned in the near future. And that's not to mention, you know, all the fun things we have planned for NERPy development, like GPU kernel support and just very basic improvements to make it more Einstein Toolkit friendly.
Okay, so the last two people who haven't commented yet are Eric and myself. So Eric, would you like to say anything about, I mean, you've already talked about CarpetX, and that's clearly been your focus and will likely be for quite some time, but any other thoughts you want to make on the future of the toolkit?
Well, regarding CarpetX, what I didn't mention is that I would be happy to invite collaborators, both on the infrastructure and on using an actual physics term to use it. Now, for the physics, that would at the moment be something like a guinea pig, because I mentioned checkpointing restart isn't working, so you can't use for productions. But I would be interested, for example, to have a hydrothorn in there, just to see that we have everything in place for hydro and that runs efficiently, etc. And I think everything else, Roland already said about CarpetX. Now, the future of the Einstein Toolkit, I think what is always important, if there's a new grant coming up, is a project that interests everybody, where everybody can go together and do something like a common thing. And it's very difficult to do cutting edge research because that requires a small number of people who focus on something and can work in secrecy to harvest the paper. But if there's a well-known algorithm, for example, M1, hi Bruno, and people could re-implement it and test it against something else. And then after a few months, we have a paper out where we compare to others, and it's something on which everybody can build. And where, I don't know, everybody, but say a large fraction of the community, plus people not here, would be interested, that is always a big community success. Now, it's always difficult to do that because if everybody benefits, nobody thinks they want to chip in or something. But if you have few people pushing that, then in the end, they are lead author on a publication that is cited many, many times. That could be cool. So I think in terms of toolkit development, I mean, of course, I personally think it's CarpetX, but also in terms of community, I think it's some physics thing, and definitely radiation transport is a very important goal there.
So as for myself, I've got a couple of things which I hope to see develop in the Einstein Toolkit. So one of which is, I mean, while our codes are well supported for 3D numerical relativity, I actually have a side project for evolving water waves, which is a 2D problem using the Einstein Toolkit. And currently CarpetX, in its state of partial development, doesn't support that too well because you can only specify number of ghost zones in all directions. You can't specify NX, NY, and Z.
Oh,
So
you
you have
can.
to-
You can.
Okay, last I looked at the PAR file, that wasn't there.
Sorry, that can be. You can have different grid functions can have different numbers of ghost zones. It's much more flexible. That was one of the lessons learned from Carpet. That is just
Right,
an
but
oversight. We can fix
I think the PAR file doesn't support that yet. But you know, it's one of these things. If you don't try to keep it working from early on, it's going to wind up developing its own little pathologies. But anyway, so that's one interest of mine. I'd like to see that really take off, and the GPU support is another thing I'd like to be involved in, because I had a project to work on that, and it never really got out of the academic stage for Cactus. Another thing, though, that we promised in the recent proposal, and which I keep thinking about, we promised a portal or science gateway for the Einstein Toolkit without really a particularly clear idea, I think, of what we plan to put in that. I've always had a vision that, well, not always I had a vision. Paul Walker, one of the original creator of Cactus, had a vision when he created something called the G code, that he could just write down some partial differential equation and the computer would spit out the answer. And he realized that was a little too ambitious after working on it for a few years, and then he scaled it back and he came up with he came up with Cactus. And I think we're almost back to the point where we can think a little bit closer to his vision, right? So when we had Crank and we had Mathematica, that could create mathematical expressions, to convert mathematical expressions on the fly into code, but it had that license restriction. So if you wanted to put it in a portal or a web server, you would have legal problems. Now we have NURPy, which does something similar. I could envision that we have a web server somewhere where you type in some differential expressions in SymPy, and that NURPy cranks on it at several levels and then can produce a result. Granted, it's still a complex problem to make those pieces work, but I think we're kind of in the place where we could almost imagine it happening. So that's one of the things I'd like to see there. I think based on, and maybe people in the audience would like to chime in, I think another thing people would like to see is ways to get neutron star and black hole initial data that matches astrophysical events or particular systems that we know about. Make that whole process a little more streamlined and easier.
Yeah,
Anyway.
like I said, I think it's certainly in NURPy's wheelhouse. As the years have progressed, more and more things within NURPy have become automated. I have my own private branch where I'm pushing on this black holes at home idea, where you can do black hole binary calculations on a desktop computer using special numerical grids, non-AMR, non-Cartesian AMR grids. But and with that, I'm developing sort of a next generation interface where it generates make files automatically for you, and full C files, not just C functions. And so with that, I think the capabilities are going to become more advanced. And I mean, the thing is, I'm worried that, as I continue, this process of, right, at some point, right, you can just abstractify everything, right? And, you plug in your PDE and then something happens. There's a big black box. And then there's something that comes out the tail end of that. And it's important to know what's in that box, I think. That's a major consideration, I think, we always have to have. So that's the reason why I wrote the full NumPy-based code, just to make everything as explicit as possible. Basically, if you were a student and you were given an assignment in a computational physics class to solve the wave equation in 3D using Python or what have you, this is what you would see. This is what you would do. You wouldn't abstractify so much. But but sort of, I think the key here is I'm going to improve NERPy documentation by moving the levels of abstraction, but have at the beginning, it's not going to be abstracted at all. It's just everything is explicit right in front of you. And now we're going to abstractify this, until finally it's almost at the level of what you described, Steve, which is, give it a PDE, it'll solve it. And, but the thing is, you'll understand what's in the black box, which I think is critically important. Otherwise, all sorts of numerical errors might prevent us from interpreting the results correctly.
Bruno.
Yes, regarding the initial data, I think there was also a request, was yesterday or the day before, from someone in the audience asking for a tutorial for using Lorraine to generate initial data. So this is something that we could do. I can also do that. I mean, I can, for example, try to prepare a tutorial on generating initial data, for example, for a single neutron star, as well as a binary neutron star system. And as far as I know, Joshua Faber is also working on a different version, I think, of the code for neutron star black hole initial data for Lorraine, if I remember correctly. So that is also something that maybe we can try to contact him in order to get our hands on. But for sure, a tutorial on how to generate initial data with Lorraine and maybe possibly also collect initial data is for sure useful.
Yeah, I think from what we saw early on, there's interest in that.
Yeah, I want to mention that for some of my papers, actually, I publish in the supplementary material the initial data for Lorraine that we used for those papers. So this is for my latest paper. If you go there, the initial data are in the supplementary. But for sure, yes, a tutorial for Lorraine is something that I think I can quite easily produce. Because it's not so complicated as, when you know what you have to do. At least for neutron star. For neutron star black hole, to be honest, it's a bit more complicated.
I noticed when stepping through the maintainers, I skipped someone because, yes, his hand is now raised because his picture was off, and so he didn't. I just didn't notice. So, Peter, would you like to comment?
Well, I've just I can update you on what is going on. I also already mentioned that in my talk yesterday, that there's, for the Cellforce code, there's certain things under development, so such as checkpoint restart capability. And when that is ready, it would be nice to have that included as well. Then there's my IU students, Joe Gibbs, who worked on the Tchaikovsky equation in Kerr. That, in principle, could be added as well. Of course, it would have to be added in stages, where first we just do the equation for the field, and then later on, with Barry's help, we will add an effective source for that, so we can do particles. But then there's also what Samuel Kopp has been working on, the Lorentz gauge metric perturbations, once we get that sorted out, and also the Vigieville-Servilli formulation of the perturbation equations. So there's a bunch of stuff on the way in progress, but it's not yet clear exactly when these things will be ready.
Also, in terms of a science gateway / portal, Peter, I think your code would be nice because it's designed to run on a single node. And one could imagine, that we just have some machine that's dedicated to that, sitting somewhere that people could just go to and say, run with these parameters and show me waveforms and so on. I'm not sure if
that's certainly something we can think about.
Yeah. I'm not sure who exactly the users of that would be, but it struck me that having a code that does real science on a single node makes that easier.
Yeah, we can talk about that.
Okay. So here's another question. Is anybody aware of any, so Peter's code is a non-Cactus code in the Einstein Toolkit, and it was always conceived when the Einstein Toolkit was created that it would be a collection of codes. Although until this last year, it's only been Cactus, and now it's Cactus plus the Cellforce code. Is anyone aware of another candidate code that could become part of the ETK?
There's a code, I believe, called GR1D. Even O'Connor was working on it. It might have been 5 years ago, something. But the beauty of that is it's a 1D code, easy to understand, and it does stellar collapse. It has Einstein equations and matter in there. And in particular, there's a student who wants to modify the Einstein equations. Hi, Helby. Then this is always a good starting point. And I've pointed people to that code, and Evan is a cool guy. So we could approach him and ask him whether that should be put in there. I don't know what that means. I mean, the code is, maybe it gives the code additional exposure, but I think that would be a good candidate.
Okay, thank you. Other thoughts?
May I just respond directly? So I think this is a great idea, Eric. And in fact, Roxana Roscamet, who was a PhD student in Cambridge, did include equations for scalar tensor theory. So she already had extended that code, as far as I know. But I don't think that that extended version is public. But overall, I think this is a great idea to have that addition for a 1D stellar collapse in there publicly.
Roland?
Maybe just to chime in, I think Eric probably already said it, but the GR1D code that was mentioned is not the extended version, but the plain version is already available publicly on Stellar Collapse with the other codes that are basically up there. But that's probably an older version, and as Eric said, one would have to contact Evan, I guess, for the newest version and to properly include it if he wanted to do that.
And translate it into Julia.
Most definitely.
So GPU coding, GPU code is obviously something that we've wanted in the toolkit for a long time, simply because there are so many top 500 machines that rely on that type of code. As I said, I was part of a project that was working on that. And while we did have something, it was enormously complex and it never really made it out of the researchy stage. So we got a couple of different papers on how to do things, but it didn't really turn into something that we could just generally use. In particular, it never really worked with AMR or anything like that. And there's a number of different reasons for that. But so in Amrex, there is built-in support for GPUs. And this seems likely the way to go, although I think there's still going to be a lot of complexity there. We were talking with the developers there, and they say that in addition to CUDA support, they do plan to support the GPUs produced by AMD. So there is an effort there to support diverse hardware and make it available. It looks like, from what I can see, it looks like the coding mechanism is similar to what's done in Cocos. You provide a lambda to do a calculation on a point, and that gets translated into something that runs on the device. Does anybody have any thoughts about GPUs for the Einstein Toolkit?
So I've looked a little bit into, so NVIDIA has a really nice set of tutorials on, for example, solving the scalar wave equation on a GPU at high finite differencing order. And I think that's one of the main complications that you're going to run into when solving Einstein's equations is breaking up the grids, slicing and dicing up the three-dimensional domain in such a way that you can efficiently access the memory as you need to, and then perform the calculation on the many CUDA cores, or GPU cores. So that's something I've just started looking into, but the more I learn, the more I realize I don't see, you know, as a point of principle, why this couldn't be done in some automated way with NeRPi. So I will, you know, continue working on this. I'll reach out at some point in the near future to anyone who's interested on the Einstein Toolkit mailing list. And maybe we should have some sort of regular discussion on this, something like a telecon, not every week, I hope, but on a regular basis, just to share what we've learned about, you know, generating code for GPUs, because there's a lot of good documentation out there, and it sounds like you've made some great strides in the right direction as well, Steve. So I'd like to learn from those of you who looked into this far more in far more depth than I have, because, you know, if I can learn it, I think NeRPi can learn it, and then we can have an automated code generation infrastructure for doing it.
Bruno.
Yes, a question. Does Exceed provide any support for groups that would like to port their code to GPU? I'm asking because in Europe, I know that there is some funding available, and I know that the Supercomputing Center in Bologna in Italy tried to apply for that, for some astrophysics code. But unfortunately, the Einstein Toolkit was not included in the, well, anyway, that grant was not approved anyway, but the Einstein Toolkit was not included in the code that they wanted to port to GPU, because they told me they see the Einstein Toolkit as a code developed and mainly maintained in the United States, since it's supported by the National Science Foundation. And so they were concerned that the European Union was not going to fund support for a code that is developed in the US. Anyway, that grant was rejected anyway, so but I wonder if there is something similar for Exceed, like that maybe you can try and convince some Exceed people to help importing the code to GPUs.
Well, the Einstein Toolkit is one thing, but if you think of Carpet X, which is based on AMREX, then AMREX might be supported. And instead of trying to add GPU support into the Einstein Toolkit as it is, we might try to leverage AMREX. And AMREX is much larger. It's used by many more people. That is, it might already be part of the grant, even if the Einstein Toolkit is not. And then we just say, yeah, we use AMREX. Please help us use AMREX as part of the Einstein Toolkit. And AMREX also has tutorials on how to define a difference in code and so on there. So the hope that I have is kind of that, since with the new parallelization mechanisms, you write routines that are much smaller, much simpler than what you did with Carpet, it would work with GPUs out of the box, because all the ways in which you need to do things different are handled by AMREX. And then in your user code, you essentially just say what you do for the individual breakpoints. There's no multi-threading, no scheduling, no nothing. And kind of the loop kernel, that would be unchanged. It can be CUDA or C++, it's basically the same language.
Okay, so there's two hands raised. Roland was raised first, so I'm gonna call on him.
Okay, so I'm going to respond to Bruno's question about whether Exceed has any support for porting codes to GPUs, and the answer is basically yes. There is something like extended user support. I think ECTS is the abbreviation that they use. That in principle gives you a software analyst that works with you porting your code to new machines. And we've tried to do that once, not for GPUs, but for the Intel mix, the what were the PHYs when they first came out, so not the Knights Landing, but the generation before, with Lars Köstaker from TAC. And the problem is usually that our code is too complicated. Most codes apparently are still assumed to be a single loop with a kernel that you iterate over, and that's where you spend 99% of your time, which we don't. So it's reasonably straightforward to port the science parts of our codes. That's why it worked well with McLachlan. And you could also port GeoHydra if you wanted to. The trouble is usually porting the infrastructure, meaning the adaptive mesh refinement code. And Carpet is one of the more complicated ones because it actually does the subcycling in time, which a lot of the simpler codes do not. And that seems to be where the problem is. So I think that's where we are actually gaining something from AMRX, because there we are gaining the GPU support in the infrastructure.
Helvi?
Yeah, I also wanted to respond to Bruno in terms of funding in Europe. You know that PRAISE also has these shortest timescale grants for code development and testing. Have you tried any of those?
No, I didn't try those, but those are just to access some resources for a limited amount of time. I don't know how much support they provide in rewriting the code. Do you know?
So I believe there's 4 different types, and I think there's at least one that also provides support. So you would have to check the Praise website, and I don't know how that changed since last year, but I would recommend to look into that on the European side.
Okay, we'll check. Thanks.
Yeah. Okay. Great.
So we have a question on the chat, which was relayed to me by Roland because I can't watch the chat and the hand raise and everything else. Bill asks whether there's a part of the core of the toolkit that we should think about replacing or changing to make going forward and maintaining and adding new research easier or quicker. Well, we're replacing Carpet with CarpetX. I guess that's one answer. And in the process of that, we can overhaul a few things. Anyone else like to say anything?
Yeah, Presync, right? That's a major update that I think we're going to need anyway in the transition, right, to CarpetX.
Yeah, so Presync is now available in the current version, and it's being baked into CarpetX. It is not without its many complications. It's surprising to me how many different ways old thorns can fail to interact with that. But we've been discovering, Roland and I and Sam Cupp have been discovering the joy of those things. Roland, would you like to comment?
Wasn't commenting on Presync, but I think, yeah, so one of the things that we learned with Presync is that we probably have to make a cut at one point and limit what will be backwards compatible. Usually we try to be very backwards compatible, but we'll have to make a cut and we will probably have to say at one point, okay, these features will no longer be supported. There's in principle a facility in place to do so, but it takes a while usually to change things. The other thing that you might see is that I guess we may slowly transition away from what we consider the default thorns for certain things. So right now, if you look at the toolkit and kind of the default stuff that we have would be you use McLaughlin for evolution. If you have a vacuum code, you have GeoHydro if you're using a fluid, and you're using multiple, say, and Wildscaler for gravitational waves. And I can see this changing that if these codes in particular do not see much development and they're overtaken by other codes that are in the toolkit, that the default would switch, and that there would be a slow change there over time. There is proposals to remove code. We carry around some garbage. So we want to, for example, get rid of a lot of the Fortran code in GeoHydro, which is now being duplicated basically in C++ code, which runs more quickly. We also have some old facilities in the toolkit that have been deprecated for years and that we want to remove. For example, some point-based, include-based mechanism to provide a stress energy tensor, which you should never, ever possibly use, given that you might spend up 40% of your time in a string compare. So there is things that we would like to do, but to some extent are lacking person power to clean up the code and patch all the fires that you're creating by taking out things and then suddenly changing a thorn that's not officially deprecated yet, but hasn't been used really by anyone for a long time.
So I guess I'd like to point out in this context that the Einstein Toolkit is head and shoulders above a number of other scientific coding projects I'm aware of because of its standards of testing and reviewing and ensuring that things run on multiple platforms. Many other codes just don't do that. I mean, there's another code I know of, which I won't name, that I work with. They don't have a test suite, and whenever a release comes out, the compile breaks on several platforms, and the old tests produce different results, and so on. It's hard to get enough people together with enough discipline to achieve what the Einstein Toolkit has achieved in terms of this level of rigor. So I think that's one of the good things about this project within the scientific community. So that's maybe another thing that we can talk about is, is encouraging contribution to the Einstein Toolkit. So these people up here that you see that we've identified are people who are maintainers of the Einstein Toolkit. We don't all work in any one location. In fact, I think that at most 2 of us work in any given location. And we're always looking for new people to become bigger contributors to the toolkit. If you do, there is a path for you to get credit through our DOI. There are multiple opportunities for you to advance your careers and contribute. Yeah, so we've had turnover of a number of different people over the years since this project began essentially in 1997. So I'd like to, I encourage you out there who are listening to think about how you can contribute, or if you'd like to, or whatever. We would love to hear from you. We would love to have you on our regular weekly calls. Would anyone else like to say anything about contributing to the Einstein Toolkit? Maybe say something about how you got involved and what it's done for you. Come on, raise your hands. People are being shy. All right. Well, hopefully, you users out there, or your attendees, will not be shy about this project. You'll think about ways that maybe you can become more connected to it. While this particular workshop has been online, a number of them are normally they're physically located either in the US or in Europe. We've generally had one in each location per year. And these have been nice trips that afford us a bit ability to see other cultures and other ways of looking at science, and to gain a lot of social interaction and experience that way. So there are a lot of things to benefit from working more closely with this community and becoming involved in the groundbreaking science that's currently happening in general relativity. All right. We are coming up to the end of...
Steve?
Yes.
I would like to make one comment about the title maintainer. I never liked it because it sounds as if the maintainers are the car mechanics that get their hands dirty and everybody else is a passenger and lets themselves drive around. And that's really not it. I think instead of maintainer, it should be called editor. Books are edited, journal articles are edited, and the editors do an important amount of work. And sometimes they look at articles and review them, I mean, particular for Nature papers, but not all the time. There's a lot of work that comes from other people. And in principle, it should be most of the work. Sorry, noise here.
That's okay. Many of us have children. Yes, no, Eric.
I think I got my point across. And I want to push for calling us editors instead of maintainers. I mean, with an explanation, but maintainers can too easily be misunderstood. I know there's a grad student and they're a maintainer of the Einstein Toolkit. That really doesn't look good on their CV. But if there's a postdoc and they're editor of a large software package that's been around for a decade, that carries some weight.
That's interesting. I hadn't thought of it in terms of how that looks. Unfortunately, research software engineering isn't as widely recognized as a field as it should be. So editor probably would carry more weight. I hadn't thought of that. All right. We have 5 minutes to 12, so we've got 5 minutes left in the schedule for the day. I'm looking for any closing thoughts any of you might want to share with our assembled workshop participants on the Einstein Toolkit, its future, its value, so on. So just at one, yes, we have Yuan Chuan Zhu. What would you like to say?
Yes, here I am. I'm original from China, and you may see some Chinese names from the participants here. And they are actually right now in the midnight and attending this kind of workshop. And yeah, my thing is it possible to expand the community to the east of the earth, and maybe sometime later you can hold a kind of workshop in the China's time, and maybe after the COVID-19 can go to China and make some kind of advertisement or spreading. And
That would,
there will be many students and staff, faculties are very interested in the Einstein Toolkit.
That's a cool idea. Just shift the time zone. Yes, I mean, if we want to do it soon.
yeah. So I picked these times because it worked for Europe and the U.S. Obviously, I can't pick something that works for the whole globe, but China is. It would be nice to. Well, okay. So we did do a workshop for the Einstein Toolkit in China back in 2013. Maybe you missed it.
Yeah,
but I would certainly be welcome. I would certainly be interested in trying to put something together, and even if maybe it's only something that's timed better for China, you know, and it's virtual. But yes, we would definitely like to see more contributions from China.
Yeah.
Thank you.
Yeah, or not China, because there's actually someone in the chat who Jay pointed out there's also India. So essentially, you know, on the eastern side of the globe. And I think that's a great idea because the idea is to build a community and to be inclusive.
I guess instead of thank you, Yuan, I should have said shishi.
Yeah, I recognize. Thank you. Thank you.
All right. Anybody else have any closing thoughts?
Yes, Steve, just related to the previous comment, Yuan Chan. So if everything works out with the COVID situation, et cetera, I hope to be living in China for a year, starting a year from now.
Okay.
So I'd be happy to, you know, help in whatever way I can when I'm there. I'll be in Hefei or Hangzhou when I'm there. So that's kind of centrally located. So and certainly accessible through the bullet trains. So it might be an idea to organize. So if you're interested, and of course, if things work out, fingers crossed, I would be interested in, I'd be happy to help out.
Yeah,
I'm looking forward to seeing the workshop you organize in China.
I didn't offer to organize it. I just said I'd be happy.
Oh, okay.
I don't think I have the appropriate amount of guanxi if the Chinese attendees here understand what I'm saying.
Well, maybe you can figure out a way to make something like that happen while you're there. That would be nice. All right. It is noon. That's it for today. I thank you all for attending. As far as lightning talks, which is a small way to contribute just to this workshop, those are still available, and you can sign up for that. I will be sending out an email again. But you can use the same links from yesterday's email to see the video after it's post-processed. very slightly post-processed. The post-processing is going to take place over the next week, and we'll break it up into individual talks, and we'll have an entire virtual online workshop. But anyway, thank you for attending, and thank all our speakers and everyone. We look forward to seeing you tomorrow.
See you. Bye-bye.
Thanks, everybody.
Bye-bye.
Bye. See you.
Bye.
Bye.
Bye-bye.